It's like I don't care about nothing, man. Yeah. Oh,
What's going on, guys? Coach Carr here. This video is going to go over a few different things, like the difference between a bar graph and a histogram, the stem and leaf plots, and probably most importantly, the 5-number summaries with the box and whisker plots. So I hope you enjoy. Okay, so now we are continuing with the notes, starting with the bar graph. So just to not use up as much time in the video, I'll do a little bit of movie magic. Okay, so now it's magically here.
Hey! Wow!
For the bar graph, bars can be vertical or horizontal. Bars and have a uniform width and are uniformly spaced. The lengths of the bar represent values of the variables being displayed. The same measurement scale is used for the length of each bar. So the pros for the bar graph is it can be used for both quantitative data and qualitative data. So I gave you an example of a bar graph on here. Now the cons, it's hard to determine fractions or find percents in your data whenever you have a bar graph. Probably the most important thing on this page, though, is the difference between a histogram and bar graph. So a histogram's bars touch and plot only quantitative data with ranges of the data grouped into bins or intervals. Bar graphs do not touch.
Touching me! She's touching me!
I'm not touching you.
You're touching me!
Not touching.
Touching me!
And plot categorical data, so it can do the quantitative or qualitative. So that might be something important maybe on the test. So next we have our stem and leaf plots. This is the method of exploratory data analysis that is used to rank, order, and arrange data into groups. Left group of digits is called the stem. The groups on the right is called the leaf. The pro for it is it organizes group data but allows us to recover the original data if desired. So it organizes and puts them into groups. When to use? You want to use it when you're showing a medium to small amount of quantitative data and want to see specific data. So just under what I just talked about, you have an actual example of a stem and leaf plot. So they tell you if you're trying to do 32, 3 would go in the stem, 2 would go in the leaf. So this makes it so you can see each of the different numbers. So the con with this, it's not good when there's a large amount of quantitative data. Also not good for showing generalized data. So if you can imagine if you had a lot of numbers in a number line, you're trying to put them all in there, it could take a long time. That's why it's not very good for large amounts of data. So for stem and leaf plots, the first type we might see is a bell-shaped curve, and this is going to be the most common. So you'll have a section that will be bigger in the middle, and it's roughly the same on each sides of it. So this is giving us our bell-shaped curve. So the next one is our U-shaped curve. It's often two bell-shaped curves next to each other. This might mean that the data that you plotted can be split into two groups. And you notice I did an arrow because I made a boo-boo.
What an idiot.
I meant for this picture to be here and this picture to be here. So this picture is the one that's the U-shaped curve. And this one will be our J-shaped curve. A J-shaped plot is not as common. As you see in the example above, the plot looks like a portion of the bell-shaped curve and occurs because the data values cannot go above or below a certain value. In our case, the number of the movies of a person watched must be greater than 0. So again, I accidentally had these in the wrong spot. So just make sure you're wary of that looking at the notes. Now the last one we have on here is rectangular or uniform. This because there are upper and lower limits on the possible values for the data, and the data values are equally spread through that range. So if you notice, just like the histogram example where it was rectangular or uniform, they're all very close to being the same length, but they necessarily don't have the same amount. But as long as they're all close, we can call it rectangular or uniform.
We are same, but different, but still same.
So on this page, I'm only going to do one, and then I want you to do all the rest of them.
Boo! You stink!
But this is creating a stem and leaf plot. These are the numbers that we're using, and I have the stem and leaf plot on there for you. Now, when we make these, we want to make sure we do a key. So I said the key is when I have a 1-1, that means it's 11. So this 1 in the stem, 1 in the leaf means that's 11. So I went through each of the numbers and put them inside of here. And you want to make sure with the leaf that you go in order of the numbers that you have. So now probably perhaps one of the most important things from this packet is the box and whisker plot. This has a 5 statistical summary of the data set, dividing the data into quarters, so 25%, from left to right on the diagram. So you have minimum, first quartile, the median, or Q2, third quartile, and a maximum. Outliers when present are shown as a separate dot or asterisk. So the pro for this is the median is readily available, so you can see that very easily. This works really well for large data sets. So in this example here that you have underneath, if I were looking at it, 1 would be my minimum, 3 would be my first quartile, 5 would be my second quartile, 7 would be my third quartile, and the maximum would be 10. Now the con whenever we use a box and whisker plot is you cannot determine if a specific value is in the data set just by looking at it. So I don't know if 6 ever truly showed up. And technically 7 might not have shown up because of we're dealing with medians. So we cannot look at specific numbers when we're using a box and whisker plot. So the 2 pages before this was the practice, and it goes step by step on how to find a 5-number summary. So I don't think I need to read it all through for you. I'll let you read it and go at your own pace. But in that example, it had 17 numbers to choose from, or that it had in the number set. I want to show you one that has an even number, and in this case, this one has 10 numbers in it. So when we find our median, our Q2, we would want to go inside and find the 2 middle ones. In that case, it would be the 12 and 14. With the 12 and 14, we add them together and divide by 2. That's how we got 13 as our median, because we don't have a true median like you would if it were ever a odd number of numbers on the line. So in the example that you had before, when it was the odd number, you don't use that number anymore. But in this case, whenever you have an even number, when we find our Q1 and our Q3, we actually use the numbers that were involved. So to find Q1, I actually used the number 12. So we went in there, went to the middle, and found our middle numbers were 8 and 10. So we add them together, divide by 2. That's how I got Q1 to be 9. Now on the bottom, we actually use the 14. We go to the middle, and we're left with 19 and 20. So I added those together, divided by 2, and got 19.5. So these can have a decimal for your answer. So in the example 2, our minimum was 1, Q1 was 9, Q2 was 13, Q3 was 19.5, and the maximum was 23. So now I went ahead and moved it down a little bit lower so you can see the box and whisker plot that I created. I decided to go by 2s to be able to see everything. And so my minimum here at 1, Q1 here at 9, Q2 at 13, Q3 at 19.5, and my max was 23. So in the box I have the 9, 13, and 19.5.
So that's the end of another video. Main things you should have got from this is knowing the difference between a bar graph and a histogram, how to make a stem and leaf plot, and how to make a 5-number summary, which we actually had some practice in class, but it's good to go over it again and have a little bit more in front of you on how to do it. But that's it. So I'm going to check this off, and y'all have a good rest of the day.